future engineers? Really? Just one?
I'm like halfway.
You're halfway there. Like halfway out?
Halfway in.
Okay. Medicine. My future chemists? Okay, you are all very likely going to take a course called Differential Equations in college. A full course, a full semester long course. Do not go into that semester-based course and say, oh, I've already got this under control. I studied it for 10 days in high school. The stuff we're going to do for the next 10 days might get you through 2 class periods in your differential equations course. But for my physicists, my engineers, my mathematicians, all the folks, you are going to do so much in the world of differential equations. It was probably one of my favorite classes because it was all about applications. My AP Physics students were going to do all the stuffs. So there's 4 big skills that we're going to go over today. This is going to be a great opportunity to just get some good notes, get some good model problems. These are just all the different things that you might be asked to do when it comes to differential equations. The important thing though is when I'm saying differential equations, you're going to say differential equations a lot, and all that means is an equation that involves derivatives. Okay? Often we're going to be asked to solve these differential equations. We're going to use these differential equations for modeling, all the things. But differential equations is just an equation with a derivative. So, for example, I want to determine the function y equals f of t, which satisfies the initial condition y of pi equals -2, and the differential equation dy dt equals secant squared of t over the cubed root of 8 plus 2 tan t. Does this count as a differential equation? Because it's an equation that has a derivative. Done. Not done with the problem, but this is definitely a differential equation. What we're being asked to do is to solve the differential equation, meaning find the original function. Find a function that has this as its derivative. Trust the instincts. What are we going to do? If that's the derivative and I want to get to the original function, what are we going to do? You're going to find the answer. Trust the instincts. If this is the derivative, then to get to the original, we're going to find the antiderivative. The antiderivative secant squared t over the cubed root of 8 plus 2 tangent t. We're going to integrate with respect to t. Have a quick strategy conversation. It's been a while. What are you going to do? So I need to find the antiderivative of secant squared t over the cubed root of 8 plus 2 tan t.
So it would be 8 plus 2 tan.
Okay, I heard it from a whole lot of the groups when I walked around. The idea that seems to be on everybody's mind right now, substitution. Right, you've got a really ugly integrand. I would try substitution. Jonathan, if we're going to try substitution, what's the baby?
The denominator?
Probably the denominator. But now I've got this cubed root of the 8 plus 2 tangent of t, and normally when we pick the baby, if there's something underneath the radical, like that's normally the thing.
Yeah.
And so you might say, all right, well, is that the right choice? Is u equal to 8 plus 2 tangent t the right choice? How do I know that I've made the right choice? Oh my God. Edgar! Hello, Edgar! Welcome back. How do you know that you made the right choice?
We take the derivative of that.
You're going to take the derivative of this. We're going to find du dt. Derivative of 8, 0. Derivative of 2 tangent t. Secant. Not secant.
Where?
Hopefully
Plus.
the derivative of tangent t is secant squared, because we get secant squared in the numerator. Okay, so the derivative is 2 secant squared t, right? Your next move, normally we would do a little multiplication here. So du equals 2 secant squared t dt. All right, I kind of see it. I made a good choice. If that's the baby and that's the derivative of the baby, I can kind of do some rewriting here. Right, but what do we normally do? Let's see, with you guys, normally you tell me to multiply by a half. So 1/2 du equals secant squared t dt. Great, so my integrand, instead of writing secant squared t dt, that's going to be my 1/2 du. Instead of cubed root of 8 plus 2 tangent t, cubed root e. It's been a little while, but not that long. Take a minute, see what you guys can do with this while I go take attendance. 3, 6, 10, 14, 18, 20, t1, 3, 6. Ah, one times.
If you have a you mind if I write? You mind if I write? If you what is this to? So if I put this to 8 and put this 3, so we're writing this. If it was just a 2, how would you write it? Or you would write it. So then
All right, so I heard Mariah say take that 1/2 out. Mariah, why can you do that? Okay, I can take that 1/2 out, it's a constant, so now I've got 1/2, the integral 1 over the cube root of u du. Next move, Jennifer Ortega. What would you do from here? You want to plug in the derivative? Do you mean like replace the u and the du? I wouldn't want to do that yet. The reason that you do integration by substitution is to get to something that's easier to work with. Easier for you to find an antiderivative of. If I want to find the antiderivative of 1 over the cube root of u, I don't want to plug back in yet. I need some clever algebra. Jonathan, you got some clever algebra?
Change cube root of u to negative 1/3.
Okay, so cube root of u is the same thing as u to the 1/3, right? And then I heard you also say at the same time 1 over u to the 3rd, you're going to make that u to the negative 1/3 du. We're mostly clearing out the cobwebs? Okay, antiderivative u to the negative 1/3. Christian, what's going to happen here?
Now you're gonna have to add 1 to the top.
So we're going to add 1 to the exponent, negative 1/3 plus 1.
2/3.
2/3. And then you're going to have 1 divided by 2/3. Everybody knows that's really 3/2. And multiply by the half. Plus c. 1 divided by 2/3 is 3/2. 3/4 u to the 2/3 plus c. Like it, don't love it. Can't call that the final answer. Jasmine, why not?
You need to rewrite what you use.
Now you need to get that u back in there, right? So now I'm close. I'm going to say, oh, that means that y equals 3/4 times 8 plus 2 tangent t to the 2/3 plus Charlie. This guy right here, because it still has the plus c, we're going to call it general solution. A general solution just means any equation of this form will satisfy the original differential equation. I still have the plus c in there. If they gave me extra information that helps me figure out the c, then I can move from this idea of a general solution over to a particular solution. Did they give me any more information? Adriana, what do you got?
They told us that y of pi it has to be equal to -2.
Right, this y of pi equals -2, this guy over here is your initial condition. So I just need to go through and figure out what's the value of c that makes this work. If y of pi is -2, if I let t equal pi, the y value is -2. So -2 is equal to 3/4 8 plus 2 tangent pi to the 2/3. Yes, a little bit mean. tangent of pi?
0. To 0.
Tangent of pi, if you're not sure about tangent of pi, maybe try sine of pi over cosine of pi. Sine of pi is 0. So tangent of pi is 0. Nice job, Jose. Negative 2 is equal to 3/4. 8 plus 0, so just 8 to the 2/3 plus c. Oh my god, we're like on the threshold here. Now I just need to figure out 8 to the 2/3.
4.
4. Ramir, why 4?
Because 2 times 2 times 2 gets you 8. But
So
So that's the
the
cube
3
root.
is the cubed root, right?
Right.
Cubed root of 8 is 2. 2 squared. 4. So 3/4 times 4.
1. 3.
Oh, golly,
Three.
it was a long
Three.
weekend. 3/4 of 4. 3. Yes. If you had 4 fingers and I cut off 3/4 of them, that would be 3. So negative 2 equals 3 plus c. C is negative 5. Not your final answer. Still not the final answer, Anthony. Your final answer, y equals 3/4. 8 plus 2 tangent t to the 2/3 power plus 5. This guy here, now that we know what the value of c is, we're going to call that a particular solution.
Is it minus 5?
It might be minus 5, Marvin. Thank you very much. I knew something felt wrong. The force is strong in me. Okay. Congratulations. We just solved our first differential equation. But honestly, in this problem, other than some challenging stuff with integration by substitution, there was nothing new. No new techniques, no new skills. It was just, I gave you the derivative, go figure out the original function. Everybody okay? All right, so let's build up some new skills with these differential equations. Some of the other things that you're going to be asked to do is show that a function or show that a curve is a solution to a differential equation. This first one, they gave you the derivative and said, go solve it. Sometimes they're not even going to ask you to do that. They're just going to ask you to show that that curve is a solution. So in this one, show that for any constant c, the function y equals the square root of x squared plus 4 is a solution to the differential equation. Well, what does that mean? What does it mean if a number is a solution to an equation? Knowing me.
So that equals y.
Well, that is equal to y. But for example, let's say I asked you guys, what are the solutions to the equation x squared minus 4 equals 0? Don't overthink it. What are the solutions here? X equals 2 and x equals negative 2 are the solutions. So what does that mean? Why are we calling them the solutions? It makes it true. What else?
And the variables plug in.
When x equals
Right, if I were to take x equals 2 and I heard some folks just say, like, if I plugged it in, you'd get something that's true, right? If you said, let me put x equals 2 in here, I'm going to get 0. Would x equals 4 work as a solution?
No.
No, because 4 squared is 16 minus 4, not going to be 0. X equals 4 is not a solution. Right, think back to the days of like algebra 1 or algebra 2. You might be asked to solve a problem like this on the multiple choice part of the test, and maybe you couldn't factor. Maybe you didn't remember what to do. What's the smart thing to do in a multiple choice test? You don't remember how to find the solutions?
Plug in the answer.
Right, you just plug them in. You go through your answers and you plug them in and say, did it work? We're okay? That's kind of the idea that I want to go through here with this one. They're saying that this guy here is a solution. All they want you to do is prove it. So the proof is going to look something like this. I'm going to start at LHS. You guys might remember that from last year in pre-calc. No, not Lamar High School. Way back in the good old days when you guys were doing proofs with Mr. Salhotra. LHS stood for the left-hand side. Okay, or maybe not. So the left-hand side of this equation says x squared plus 4 times dy dx. The dy dx means the derivative, right? The left-hand side says start with x squared plus 4 and multiply by the derivative. Well, if y is equal to c times this square root of x squared plus 4, just take a minute real quick. Go find that derivative for me. C is the constant. Y equals c times the square root of x squared plus 4. Find the derivative. Maybe you're thinking a little bit of chain rule. Okay, quick little nudge if you need it. The derivative of the square root of x is always 1 over 2 square roots of x. So the derivative over here, c is a constant, leave it alone, will be 1 over 2 square roots of x squared plus 4 times 2x. Jose, why are we multiplying by 2x? It's the derivative of the stuff, right? It's the derivative of that baby. We just did a little chain rule. So the left-hand side says if I take x squared plus 4 times that derivative, so x squared plus 4 times the derivative, c times 1 over 2 square roots of x squared plus 4 times 2x, somehow I'm going to get just x times y. I'm plugging that value in to the left-hand side, and I'm just working this out. Looking for some good, clever algebra. Where's the clever algebra? Any legal things that we can do with this expression over here? Legal algebra. Nobody sees it? Okay, I'll give you a little nudge. 2 in the denominator. That 2, I can cancel those out. You've got x squared plus 4 in the numerator. You've got the square root of x squared plus 4 in the denominator. X squared plus 4 up here, square root of x squared plus 4 down here. They will cancel, but you have to be careful about this. Because this is really x squared plus 4 to the first power. This guy is really like x squared plus 4 to the 1/2 power. Bases are the same. If the bases are the same and I'm divided, you're going to subtract. So what you're going to get left with is going to be c times x squared plus 4 to the 1/2 power. Way back in the day when you guys were doing trig proofs, and just like what we're doing now, you start on one side, only working on that side. Your goal is to get the other side to show up. The goal is to legally get x times y to show up. Well, let's see, I've got c times x times all this stuff. Well, that's the same thing as c times x times square root of x squared plus 4. C times x is the same as x times c, so I'm just going to rewrite those. And that c times the square root of x squared plus 4 is the same thing as y, because that's where we started. We started on the left-hand side. We just did some legal manipulation of the derivative. We did some algebra stuff. And what you get is exactly the expression on the right-hand side. What that would tell me is that, yes, this guy over here is a solution to the differential equation. That didn't go over nearly as well as I thought it was going to when I envisioned this lesson last night. But the first one went well. Okay. Let's come back to that one in a little bit. All right, see what you guys can do with this one. I want you to show that for any constant C1 and C2, this guy here is a solution to that differential equation. So I'm giving you a curve involving C1 and C2. C1 and C2 are constants. And I need you to show me that it actually is a solution to d squared y dx squared plus 4y. Before you guys get started, d squared y dx squared means
The second derivative.
second derivative. Okay, so let me get out of your way. Give you guys a little bit of time to play around with this one. That's the original function. That's the differential equation. I want you to show me that this guy actually is a solution. So we get your calculator out the first.
Yeah.
Okay, so please do.
So we should just find something good that what
All the friends over here.
you take it out.
You guys all successful? Get out.
Cosine? Do we say cosine? We always say sine.
Did you guys all successfully get out? Press the touch button.
Yeah, no one does say. I just said sine, cosine.
So I'm not saying no, I'm just saying.
No one said that. I'm just saying that.
I'm just saying.
You abbreviate when you don't abbreviate on sine. Because sine is a short.
I just
Yes, so cosine.
cosine and long.
Sine.
I thought it was sinusoidal.
Yeah. Sinusoidal? Sinusoidal. I thought you were Sinusoidal? Yeah. That's what it's called.
That's a long word.
But that's like the shorter version of the long version. But then it's like the shorter. I don't know. There's probably a long word for sinusoidal. I don't know. Oh, it's the mom and the baby. So you find the derivative of sine. So it's negative of 2x times 2.
Just if it's a derivative, then it's probably cosine to
Again. Wait, it's negative cosine? Or is it positive? Positive.
You leave C1 and C2 as they are, right? Because they're constants.
And then the derivative of cosine is negative.
Wait, but hold on, we should be able to do it part B.
So for my second,
find the derivative.
All part A, we should be able to do
Alright,
So
yeah.
you don't right there.
for the second derivative, I got C1 times negative sine of 2x times 2 plus C2 plus 4y.
Is it two? But it's not the time.
Wait, could you, I just think about it, you turn it into 0 and then it's all a 0. And then we'll see if it's
Man.
Okay, just a quick show of honest hands here. How many guys have that as your first derivative? 2 times c1 times cosine 2x minus 2c2 sine 2x. Okay. So now I need the second derivative. I need d squared y dx squared. So take derivative again. 2 and c1, both constants. So the derivative of cosine is negative sine of 2x times 2 minus 2c2, derivative of sine is cosine 2x times 2, and if you want to clean that up, maybe make it negative 4c1 sine 2x minus 4c2 cosine 2x. How many of you guys honestly made it? That is your second derivative. Nice job, David. Okay, so let's go back. I think this is where I lost you guys before. Let's go back to what it says on the left-hand side. The left-hand side says, if I take the second derivative, that guy over there, and add on to it 4 times y, 4 times the original function, will I get 0? So take your second derivative, this negative 4c1 sine 2x minus 4c2 cosine 2x, that's that second derivative, plus 4 times the original function, c1 sine 2x plus c2 cosine 2x. Is that going to get you 0? If it is, what's the legal algebra that's going to get you 0? Legal stuff only. Adriana, see some stuff? This first part is your second derivative. This guy here is 4 times the original. Legal algebra. Adriana, what could you do?
You could distribute the 4 into the c1 times sine 2x.
Is it legal to multiply everything by the 4?
Yeah.
Sure. And if you do that, what happens?
They cancel out.
Right, now you're going to have 4c1 sine 2x. Hey, good news, I had a negative 4c1 sine 2x. Those cancel. Keep distributing the 4. 4c2 cosine 2x. Up here, a negative 4c2 cosine 2x. Those guys cancel and you get 0. That's what was on the right-hand side. So the proof's done. You made it. When they tell you what the solution is, it is just a matter of plugging it in to make sure that it works. And if for whatever reason you couldn't get 0 as the answer, then that would tell me that this guy here isn't actually a solution to the differential equations. Everybody mostly okay? All right, so I want to push one more time. I'm going to offer no help in the beginning because I want you to trust your smarticle particles. Ice is forming on a pond at a rate given by dy dt equals k squared to t, where y is the thickness of the ice in inches at time t measured in hours since the ice started forming, and k is some positive constant. At t equals 9 hours, there are 4 inches of ice on the lake. I want you to find y as a function of t. I'm going to give you 2 minutes or so to try this. Trust the instincts. This is just another differential equation. Trust the instincts here. And feel free to talk to whoever you're sitting next to. 2 brains are better than 1.
Try to find that. K is a positive constant, so it has to be one half. It's like outside. It's like this. Just one of the goes outside. So it's T or
Even
zero. Wait, 3/3 is one.
Okay, when it says T equals 9 hours.
Oh, why you put K equals that? K does not equal
9
that.
hours and that equals 0.
T to the 1 is T to the no, yeah. Oh, now we do the addition condition. Plug in 9. Plug in 9.
Are you ready? Am I being extra?
No, I think
If that's where we're
All right, so I see most folks said, all right, if I've got a differential equation, right, they gave me the derivative. They're asking me to find the original function. How am I going to go from the derivative to the original function? Antiderivative. Trust those instincts. So y is going to be k times the square root of t dt. And I think there is some initial confusion with what's happening with this k. Because it looks like a variable, it feels like a variable, but Mariah, what do you know about k? It's a constant, so you get to do your favorite thing with the constant. You get to pull it out in front. So y is going to be k times the integral, square root of t. Most of you guys were sort of right away rewriting this as t to the half. Antiderivative of t to the half,
2/3.
right? Add 1 to the power, divide by the new power. So y equals k times 2/3, t to the 3/2, plus Charlie. Don't forget about Charlie. Not the final answer. Because? Why is this not the final answer, Jennifer?
You need to find what C is?
You want to figure out what C is. I agree. You want to figure out what C is, and you need to figure out what K is. Now, I think at some point, if you read the question carefully, at t equals 9 hours, there are 4 inches of ice on the lake. Right? That's an initial condition. Right? They're telling you the start. They say if t is equal to 4, y is equal to 9. If I let t equal 4, y is going to equal 9. Great. There is, however, another initial condition that I haven't heard anybody mention yet when I was walking around during group work here. There is a hidden initial condition. There's another time where you know how much ice there is. 2 people? There, I'll say it one more time and give you an opportunity to just go back and read. There's another time where you know how much ice there is. Marvin, what is it?
T equals 0?
At t equals 0, how much ice?
0 to 34.
Right? They're saying, why is the thickness of ice in inches at time t measured since it started forming? So this hidden condition, and I don't know it's technically called a hidden condition, but let's call it that. Okay? The hidden condition says if t is equal to 0, y has to be equal to 0. So let's see what we can do with that. So if t is equal to 0, y is 0. 0 equals k times 2/3. 0 to the 3/2 plus Charlie. 0 to the 3/2.
0.
0 times 2/3.
0.
Times k.
0.
0. Guess what?
Charlie 0.
C is equal to 0. So y is going to be k times 2/3 t to the 3/2 power. Now, go use the other condition. And if all goes well, you should be able to pretty quickly tell me what the value of k is. Finish that off. And if anybody's got any questions, now would be a great time. T should be equal to 9. Thank you for that. Strike 2 in one class period. Times 2/3, 9 to the 3/2 power.
I divided wrong.
9 to the 3/2. Square root of 9.
Oh,
3. Cubit.
27.
27.
Oh, I did it.
So now I need 2/3 of 27.
K equals 4 over 18.
2/3 of 27 should be 18. So K is 4 over 18, 2/9. Final equation, y is going to be 2/3 times 2/9 t to the 3/2 power, or even better, 4 over 27 t to the 3/2. How many of you guys honestly came up with 2/9 for k? Okay. Some people, not everybody. Once you've got k, you're just going to go back in and plug it in. I think for the most part, when I was walking around, everybody felt really good about this problem after like a little bit of time to think about it. I think the tough part was that hidden condition. It's not going to happen a lot. I think especially in this unit, most of the problems are going to be kind. They'll tell you what the initial condition is, but there's one more way that I'm going to push. And it's just a quick review of some vocabulary. There's two ideas that I need to just put out there right now. Directly proportional. And if you're Marvin and you were hanging out with 9th graders, are you still helping 9th graders in the morning? Oh. Okay. Marvin, I need you to just not chime in on this one because he hangs out with the 9th graders in Algebra 1 and they do this all the time. Directly proportional and inversely proportional are words that you've picked up somewhere in the math vocab. What do you remember?
Isn't directly proportional if one is increasing, the other has to increase. If one is decreasing, the other has to decrease.
Say that one more time.
If one is increasing, the other has to increase, and if the other decreases, the other has to decrease. They have to go the same way.
You didn't say the word it, so that's really good. In place of the word it, you used other. Directly proportional. One goes up, the other one goes up. Okay, so here's an example. I was at North Central last week during a fire drill. And all the teenagers were trying to go through one door to get into the building. Okay? The number of teenagers trying to get through the door and the amount of time that it takes for them to all get through the door. Would that count as directly proportional?
No.
The number of teenagers trying to get through the door, the amount of time it takes them all to get through the door. If one goes up, does the other one go up?
Yes.
The number of teenagers trying to get through the door, the total amount of time it takes them to get through the door. The more there are, the longer it takes. Better example. If my wife and I win the lottery this semester, which will be incredible since we don't play. In the event that we do, here's the standing plan. For every one of you that passes the AP exam, we will pay out $1,000 to you for college tuition. The number of you that pass the AP exam and the amount that we pay out, is that directly proportional? One goes up, the other one goes up by the same number of times. There's a proportional relationship. Everybody okay with directly proportional? Okay, so with directly proportional, we're going to say very directly, or they're proportional, or directly proportional. So if you've got two variables, we're going to say that y equals k times x. In Algebra 1, that's the equation that you guys use, or the students in Algebra 1 are using these days. K is called your constant of proportionality. Constant of proportionality. Wow, don't know what just happened at the end of that word. Ron, are you okay back there? Okay. If I was a scientist, I might write y alpha x. No, it is not the Jesus fish. I'm not being mean or rude, but everyone's like, that looks like the Jesus fish. No, it's not. It's not the Jesus sign. It's y alpha x. Y is directly proportional to x. Or x is directly proportional to y. This is what you guys do in science class. All right, inversely proportional. One goes up, the other one goes down. Okay? So let's go back to North Central and the fire drill. So I was standing up at the top of the stairs at the end of this fire drill, watching all these teenagers come through. Let's let the number of teenagers be constant. They are all trying to get through one door. Hundreds of them going through one door. And then I'm standing there and I realize there is a second door. I opened the door. What happens?
There's more.
No, there's not more teenagers hiding. In terms of the amount of time it takes the teenagers to get back into the building. I opened the second door. The amount of time decreased, right? Theoretically, in this perfect world, because I opened a second door, what happens to the amount of time?
You save some.
Not only did I save some, in this perfect world, I opened up a second door, I cut down the amount of time it takes in half. If there was a third door, by a third. So let's go back to the lottery example here. Rather than paying out $1,000 to every person that passes. Right. Right. Sorry, we're Republicans. $10,000. Rather than $1,000 for every single person, $10,000. Here's what's going to happen though. For every one of you that passes the AP exam, you get to share in that $10,000. The relationship between the number of you that passes and how much you get. Directly or inverse?
Inverse.
Right? If 2 people win, how much?
Each get 5,000.
And each of you gets $5,000. Double that. 4 people win. Oh, tough math here. 4 people get a 5 on the AP exam. That $10,000 gets divided by 4, and everybody gets 2,000 and something. We're going to be saving our money this year. 2,500. Okay, inverse proportions look like this. Y equals k divided by x. If one goes up, the other one goes down. Some people choose to write it this way. They say that the product remains constant. The number of you that earn a 5 on the AP exam, the amount of money that you each get when you multiply those two together, it's going to be $10,000. Okay, you could also say y alpha 1 over x. So with all that said, I want to come back to this problem that we just did one more time. This is how it is more likely going to show up. So go back, read through this question one more time. Another way this question could be asked. We'll have a conversation in a minute about what's different. This is how you are likely going to see questions like this. Ice is forming a pond. Let y represent the thickness of the ice in inches at time t, measured an hour since the ice started forming. The rate of change of the thickness of the ice with respect to the time is directly proportional to the square root of the time. At t equals 9 hours, there's 4 inches of ice on the lake. set up and solve a differential equation which can be used to model this situation. What's the big difference?
They don't write out.
Right, they didn't give you the differential equation. They didn't like, give you the math of it. Instead, they wrote it out in words. Right, and it's here in, what is this, the third sentence? Okay, key word that I want you to focus on here, not Keith. Directly proportional. As soon as you see directly proportional, right, the thing that comes before directly proportional is equal to a constant times the thing that comes after. This is what we mean by a directly proportional relationship. The rate of change of the thickness of the ice with respect to time. Rate of change in a calculus class? Derivative. What am I taking the derivative of? The thickness of the ice. Right, that's what I'm taking the derivative of with respect to t. All that there is dy dt. This guy here is directly proportional to, it's a constant times what comes after. Stay with me for a second. Square root of the time. So if t is time, square root of t. This is the exact same differential equation that I gave you earlier, except now you had to work for it. From here, if you were going to finish it off, right, we're going to find the antiderivative, use the initial conditions, do all the things. Tonight's homework, this is on the last page. I want you guys to do 2, 4, 5, 6, and 9. It's 5 problems. It's going to take a little bit of time, but it covers all the skills that we've just talked about. 2, 4, 5, 6, and 9.